So today we're going to go over some example problems for the limit definition. A first derivative provides you with the slope on your function. So we have f of x equals 5x squared minus 3x plus 7. Our limit definition is the limit as h approaches 0 of f of x plus h minus your function f of x all over h. And for those of you that don't know, h is just referring to your change in x. So f of x plus h just means x plus the change of x. So just another x value on your graph. That's all it's standing for. So what I always tell my students to do first is to find f of x plus h from the original equation. So our original equation is 5x squared minus 3x plus 7. So in place of x, in these two locations. And always make sure you put it in parentheses. So 5 parentheses x plus h, and that x was squared, so we need to put a 2 on top, minus 3 parentheses x plus h plus 7. As I can see here, there's quite a few extra steps I can do before I actually plug this into my limit equation, so I can simplify first. If you simplify within the equation, it gets really jumbled and turns into a bit of a mess. So I'm going to rewrite this one as x plus h times x plus h, because that's the same thing as squared, when something times himself. And we're going to use the distribution property to move this negative 3 into both of these terms. Don't forget to multiply into both terms. So minus 3x minus 3h plus 7. For this, we're going to need to FOIL. Keep the parentheses. X times x is x squared. X times h twice, so x times h here, x times h here, means I have 2 xh's, so xh plus xh, and then the last two terms, h squared. So this is the same thing as 2xh. We have 2 of them, so I'm going to go ahead and rewrite this as 2xh plus h squared. We can go ahead and distribute that 5 in now, and make sure you distribute it into every single term. So 5 times x squared is 5x squared. 5 times 2xh would be 10xh. And then 5 times that last term, 5h squared. So next we look to see if there's any terms that we can combine. None of these have any like terms, so we're going to go ahead and just leave f of x plus h like that. And we're going to be using both of these equations here and plugging it into our function. So remember, the function is the limit as h approaches 0 of f of x plus h minus f of x all over h. With limits, usually you would go ahead and substitute in the 0 into the function, but if we do that, we'll have a 0 on the denominator. So if that occurs, it's called an undefined, because you can't have 0 on the bottom. Plugging in our functions, f of x plus h, we have to write this whole dude. And then we are taking away this function. We have to subtract the entire function, so always put it in parentheses. And then all of this will be over h. Since we've already simplified our f of x plus h, we can now go ahead and carry this negative in here. So carry down your limit. When you carry in the negative, it's going to change the sign of everybody within those parentheses. So if it's positive, it'll be negative, so the negative 5x squared. If it's already negative, double negatives create positives. So plus 3x. This is positive 7, so we're going to become minus 7. And this is all still going to be over h. Now I'm going to come in and see if there's anything I can cancel. F of x always cancels. The whole function will. So we have 5x squared and minus 5x squared. Those will cancel. Let's see what else. Well, we have plus 3x here and minus 3x here. Those will also cancel. And then the plus 7 and the minus 7 will cancel. If those cancel, we're just left with 3 terms on top and the h on the bottom. That means the limit as h approaches 0 of 10xh plus 5h squared minus 3h all over h. Notice every single term has an h involved. So that means we can factor an h and cancel the h on the bottom. So if I factor h out from all of these terms, taking an h out of 10x h, I'll be left with 10x. 5h squared will become 5h, and negative 3h will become minus 3. H over h is the same thing as 1, because anything divided by itself is equal to 1. So the limit of h approaching 0 equals 10x plus 5h minus 3. And now we can go ahead and do direct substitution. Direct substitution just means plugging in this 0 for h into all the places you have h in the function. Once you plug your h in from your limit, the limit will go away. So we'll just have 10x plus 5 times 0 minus 3. And to simplify that, we just end up with 10x plus 0 minus 3. So 10x minus 3 is our function for f prime of x. F prime of x, remember, is just your derivative, dy over dx, or y prime. Our next problem is going to be conjugates problem. So for conjugates, think of 2 terms that look exactly alike except for their signs. So a good example would be some stuff from polynomials, I'm sure y'all have seen before, which is difference of 2 squares, where you have an x plus 3 and an x minus 3. So the only difference between these 2 terms is that it's plus and it's minus. You change the sign between the terms. Another example would be one for conjugates. Conjugates are always when you have radicals or these square roots here. So the square root of x plus 2 minus 1, its conjugate or opposite would be square root of x plus 2 and then a plus sign, plus 1. So that's the difference for finding your conjugate. The reason why I went over this is because we're going to have to use conjugates in order to simplify our limit definition problem. So now we have our limit definition on the left, and now we have our function f of x, which will be put here in our limit definition. X plus h just takes the place of x in your function. So we will have 1 minus the square root. X becomes x plus h plus 3. So now to rewrite and plug everything in, we have f of x plus h first, which was that 1 minus the square root of x plus h plus 3, minus our function f of x. Always put this in parentheses, because we need to carry the negative to all of our terms, and then everything will be over h. Now we need to simplify. Carry the negative in to the 1 and to the x plus 3 with the square root, and we get minus 1 plus the square root of x plus 3. And all of these are over h. Our 2 1s are going to cancel. This is where we get left in a pickle. We don't have a way to cancel this h on our denominator. And if we do direct substitution of putting 0 in for h, we have a 0 on the denominator still. So the only way to manipulate this equation to find our conjugate for this term. So like I said and practiced a bit before, the opposite or conjugate, all you have to do is change the sign. So we have negative x plus h plus 3. And instead of being plus the square root of x plus 3, we'll do minus the square root of x plus 3. And then what you do to the top, you have to do to the bottom. Just like you do when you're changing your fractions to find common denominators. I recommend not multiplying this in with the h and just leaving your factors on your denominator. Now that I've rewritten everything, let's just think about the top. So now we are going to use the FOIL method to multiply our numerator out. FOIL method uses our first terms first, outside, inside, last. That is the negative square root of x plus h plus 3 times itself, which is the same negative x plus h plus 3. Outside terms would be the x plus h plus 3 negative times this other negative, negative square root of x plus 3. So plus negative square root of x plus h plus 3 times another negative x plus 3. Then we have our inside terms, which is the square root of x plus 3 times the negative square root of x plus h plus 3. One of them has a negative, one of them does not. And then we have our last terms, negative square root of x plus 3 times the square root of x plus 3. And like I said before, let's just leave our denominator alone. I'm going to go ahead and put our negatives in pink so that you can see them. And all the places that we have double negatives and single negatives. So notice that this one has a double negative and this one has a single negative. So the two negatives on the left canceled. So instead of plus here, it will be minus. Well, if they're the same terms, they both have an x plus h plus 3, they both have a square root of x, and they're opposite signs, that means I'm just taking the same thing away from it. These two terms are going to cancel. Just left with the two outside terms. So I'm gonna go ahead and rewrite it. As you learned before in high school and earlier, the square root of something times itself is always itself, because the square root of 2 times the square root of 2 is the same thing as the square root of 2 times 2, which is 4. The square root of 4 is 2. So if you ever see anything times itself, it is just the answer within it. If we look on the left side, this is the same thing times himself, which means the square root of x plus h plus 3 squared. Square root and squares cancel each other because it's the opposite operation, just like multiplication and division or addition and subtraction. So we'll be left with x plus h plus 3 minus this squared. Anything squared times himself is itself, so minus parentheses x plus 3. And like I said before, just leave that denominator alone till the end. You won't have to do anything till then. So now we're going to carry this negative in here so we can simplify it even further. So now we're going to carry this negative in so that we can simplify it even further. And we end up with x plus h plus 3 minus x minus 3. So change the sign of everybody there. We're going to see if we can cancel anything. So I see a positive 3 and a negative 3, a positive x and a minus x. X minus x's cancel. 3 minus 3 cancels to 0 as well. So that means we're only left with a term h on top and then our long denominator. The good thing about conjugates is this happens every time. Everything will cancel like that, leaving you with the h so you can cancel your denominator h. So when this cancels, anything divided by himself is 1. Don't forget to leave a 1 on top. So we have the limit as h approaches 0 of 1 over this term. When you get to this point, just use direct substitution by plugging in that 0 for h. So our derivative equals this. Can be simplified to 1 over the negative square root of x plus 3 minus x plus 3. Well, anything minus himself, we have 2 of them. So it will be 1 over negative 2 square root of x plus 3. This is the simplest form of our derivative function. So this is our first derivative. Now we're going to do an example of a rational function. Rational function just means you have an x in the denominator, and when that happens, you have possibilities of having a 0 in your denominator. Anything that causes a 0 in the denominator creates a vertical asymptote, which are just those asymptotes on the graph that change what your graph is doing. Because it's going to try to approach those vertical asymptotes, but it's never going to be able to cross them. So let's say our function is x plus 1 all over x minus 2. Our first step for these is always to find our f of x plus h for our limit definition. And a reminder, our limit definition is the limit as h approaches 0 of f of x plus h minus f of x all over h. And that will give us our first derivative, or what we call f prime. F of x plus h, you just plug in x plus h in place of x. So we have x plus 1, so parentheses x plus h plus 1 all over x minus 2, so we have x plus h instead of that x minus 2. And we don't need the parentheses in this case because we don't have any negatives that are going to carry in, so we can go ahead and rewrite it like this. Now that we have this information, we can plug it into our function. And then we subtract our original function, which was x plus 1 over x minus 2. The issue here is we need a common denominator to add or subtract fractions. The easiest way to find a common denominator when you have x's in your denominator is just to multiply by each other. Because what we want is just x plus h minus 2, which is that first denominator, times x minus 2. So you just look at what you're missing on one side and multiply it by the other. So this first term doesn't have the x minus 2 in the denominator, so we need to multiply both the top and the bottom by that value. We have to do the same for the second term and multiply by the other denominator, which is x plus h minus 2. This way they will have common denominators. This whole thing's going to have h on the denominator. So I think the easiest way to multiply these in is to use the smaller terms to keep yourself organized and multiply x by all three terms, and then multiply -2 by all three terms. So let's do that one at a time. X times x is x squared. X times h is xh. X times 1 is positive x. Next we need to multiply -2 in. So -2 times that first term x is -2x. -2 times h is -2h. And -2 times 1 is -2. Now that we have this function subtracted by the other one. So now we need to go ahead and distribute the other one in. And remember I said use the smaller number of terms and multiply into the bigger ones. So x times all three of these terms, and then 1 times all three of those terms. So x times x is x squared. X times h is xh. X times -2 is -2x. And then we take the 1 and multiply it into x, h, and -2. So 1 times x is x. 1 times h is h. And 1 times -2 is -2. I put parentheses because this negative is going to carry into every single term. Since they have a common denominator, we can put them all under the same fraction. And I can go ahead and carry this negative in, so anything that's positive will become negative, anything that is negative will become positive. X squared is positive, so it'll become minus x squared. Xh is positive, it'll become minus xh. -2x, double negative makes it a plus 2x. Positive x will become a minus x. And then positive h minus h, and the double negatives make it a plus 2. And our common denominator, x plus h minus 2 times x minus 2. And all this in the end is all divided by h. This is the step where we need to try to cancel as many terms as possible. And this is where our f of x function is going to also cancel. So we're going to have x squared and x squared cancel. Xh minus xh is also going to cancel. Our plus x and our minus x are going to cancel. Our plus 2x and our minus 2x are also going to cancel. And then we have our 2 and our plus 2. Those will also cancel. So notice pretty much every single term canceled except for this minus 2h and the minus h. So let's rewrite it. We can simplify this right now, and negative 2h minus h is negative 3h. So I have the limit as h approaches 0 of negative 3h all over x plus h minus 2 times x minus 2 all over h. This can be rewritten into a division problem, dividing by h over 1, instead of having it on the denominator there. This is the same thing. Well, when you divide by a fraction, you need to multiply by a reciprocal. Well, the reciprocal of h over 1 is 1 over h. The limit as h approaches 0 of negative 3h all over times 1 over h. I can rewrite this as negative 3h over h times our whole denominator. This can be rewritten like this, two terms together, because 3h divided by h, those h's are going to cancel each other and become 1. So we have negative 3 times 1, which is negative 3, all over x plus h minus 2 times x minus 2. We're getting to the end here, so now all we have to do is substitute 0 in for h and solve. So we have negative 3 over x plus 0 minus 2 times x minus 2, which will simplify to negative 3 over x minus 2 times x minus 2. Same thing as negative 3 over x minus 2 squared. And that would be our derivative function. And that is it for our limit definition video. I will be making more with a couple different examples that are a little bit more difficult, and I will make those all individual videos from now on. So this was the limit definition with Lauren, and good luck with your calculus.